Welcome to Holostate Design's Last Ditcher CW Transmitter Kit assembly video. This video will help you create another great Holostate project. Probably. The video will take you through the recommended kit assembly step by step. The kit is supplied with a bill of materials checklist. Now make sure all the parts are in the box, usually in plastic bags, and you can identify each part. If something's missing, email me and I'll get it out to you ASAP. Refer to the layout diagram and the schematic in the written assembly instructions in the kit. The layout of components doesn't have to be exactly as shown in the diagram. Now, unlike a typical etch circuit board, where everything must fit in the exact through-hole or surface mount locations, the spirit of this kit is home brew. I intended it to be built like you would if you were home brewing it from scratch. Now I'm going to show you how I did it. The first step is to install the phono connector and the B and C connector to the L bracket. Then attach the L bracket to the board with the number 4 screws and nuts. Make sure the nuts go on the top. Now wind the toroid inductor so it's ready for installation. The kit comes with about 28 inches of enameled wire for L1 and L2. Before winding L1, cut off about 4 or 5 inches of wire for L2. Start by winding L1, 36 turns of wire on the toroid with a tap loop near the center. The winding should take up about 3/4 of the core circumference. The location of the tap loop isn't critical. Anywhere near the center will work fine. After winding L1, wind L2 over L1, anywhere near the center tap loop. It's just 2 turns. Wire passes through the hole twice. Then cut the leads to about 1 1/4 inch and remove 1/2 inch of insulation. Bend the leads of the 7-pin socket out as shown. Then carefully place it on the Me-Tube socket pad, lining up the pins correctly, and solder all the pins to the pad. Now, I use a couple of different types of socket and pads, and the parts in your kit might be slightly different. The kit is supplied with several Me squares from Rex W1REX. Me squares, and I also call them Me pads, or just pads for short, are 1/4 inch squares of copper-clad pads, easily snapped apart and glued to the board, making connection points for components. Following the locations for the components on the board layout, first glue the tube socket pad, using 3 or 4 dabs of glue on the underside. Don't install the 6J6 yet. Make sure you orient the pin numbers as shown in the diagram. Here's a gluing tip. When installing Me squares or components to the board, I find it a lot easier to put a small drop of glue on the board and then place the pad or component on the glue with needle nose. It takes very little glue to secure them to the board. Next, glue a single Me pad between the tube socket pin 7 pad and the L bracket. Glue 4 of the Me pads that will hold the screw terminals to the board at the approximate location shown in the layout diagram and video. They should be grouped in pairs close together. Yes, in this photo, the pads on the left are upside down by mistake. Still works okay. Put 2 or 3 small dabs of glue on the nylon nut and place it where the toroid's going to go at the approximate location shown on the diagram and this photo. Let the glue dry completely. Using the layout diagram as a guide, glue the 3 Me pads that will hold CV, the small trimmer capacitor, to the board. Use the pin spacing on the capacitor as a guide. Now is a good time to solder the screw terminals to the Me pads you installed earlier. One terminal is for the filament voltage and the other is for the B+ high voltage. Now I supply two types, a black version with pins that are bent for surface mount like you see here. Melt a small amount of solder on one pad of each pair. Then, holding the terminal in place so the pins are centered on top of the pads, remelt the solder on the pad and pin. Then solder the other pin to its pad. Do this for both terminals. The other type of terminal is green with pins intended for through-hole soldering. Melt a little solder on the two pins of each block. Then melt a little solder on the left knee pad of each pair. While holding the block pins against the pads and oriented as you see in the photo, solder the left pin. Now this will hold the block in place while you solder the right pin. If the block is not straight, you can adjust it while remelting the solder before you solder the right pin. Now install L1, the toroid you made earlier, on the nylon nut previously glued to the board. Put the screw through the toroid and screw it to the nut. The purpose of the screw is to prevent the wire turns from moving. Don't over-tighten the screw, just enough to make sure the turns don't move. Orient the toroid so the L1 leads will connect to the CV pads as shown in the diagram and video. Orient the L1 lead so that one will be soldered to the pad closest to the toroid and the other to the pad closest to the tube pad pin 3 as shown. Shorten and scrape off any enamel if you need to. Bend the three leads of CV, the variable capacitor, out at right angles to the board. Solder it in place by soldering one leg to the pad that doesn't connect to an L1 lead. Don't solder the other two leads yet. Oops, I forgot the L2 leads. Solder one of the L2 leads to ground and solder the other lead to the center conductor of the BNC connector. Now I put a short piece of scrap insulation over the leads, but this is unnecessary. Now connect a short length of insulated wire from tube socket pin 1 to the CV pad closest to the toroid. Solder the end to pin 1 first. This will hold the wire in place so you can solder all three conductors on the CV pad. Using the same technique, solder another short length of insulated wire from tube socket pin 2 to the CV lead with the other L1 wire. Just another view to help clarify where the wires go. Next, connect a short length of insulated wire, yellow in my example, from the toroid center tap to the B+ screw terminal pad. The B+ side is on the left in the placement diagram. Now connect C3, the 0.01 microfarad ceramic capacitor. Solder one end to ground first, then solder the other end to the B+ terminal pad you previously connected to the toroid center tap. Solder all three connections. Next, solder a short length of bare wire from the tube socket pin 3 pad to ground. Then solder a short length of bare wire from both screw terminal ground connections to ground. Then solder a short length of insulated wire from the filament voltage screw terminal to the tube socket pin 4 pad. Why don't you? Bend the leads of the LED as shown in the diagram. The short lead is the cathode. It is also connected to this larger element inside the LED. Solder the cathode lead to the pad next to pin 7 and solder the other lead to pin 7. Then solder the 180 ohm resistor between that same pad and the center conductor of the phono connector. Next, solder C2, the 0.01 microfarad ceramic cap marked 103 from tube socket pin 7 to ground. Next, solder in the crystal. Bend the leads at right angles and solder one end to the tube socket pin 6 pad and the other end to pin 5 pad. Finally, install both 2 millihenry chokes, one from tube socket pin 6 to ground, the other from pin 5 to ground. And finally, don't forget to install the 6J6 thermotron. Now it's time to test your transmitter. As usual, double check the connections, especially check the solder joints. In this type of construction, it's easy to miss soldering a lead to a pad or ground. I do it all the time. And make sure a resistance check from the B+ connection to ground shows open. Attach a high voltage supply, a key, and a dummy load. In my case, it's just a 50 ohm resistor. If the red LED lights when you key the transmitter, it's working. Congratulations. The only adjustment is to tune CV, the tuned circuit variable capacitor, for maximum output. With the last ditcher connected to the Holostate Designs power supply, monitor the output with a scope, power meter, or using the S-meter of a nearby receiver. Using only a plastic adjustment tool, slowly rotate the adjustment screw until you observe maximum output. Be careful when adjusting the variable capacitor. The metal adjustment screw is connected to high voltage. Don't touch it and use only a plastic adjustment tool. You now have a working 40-meter CW Thermotron transmitter. Welcome to the exclusive ranks of QRP Thermotron home brewing. To measure the power out, I've got it connected here to my homebrew QRP power meter. With the power meter set to the 2-watt full-scale range, it's measuring about 1 watt, with the power supply outputting about 180 volts. The last ditcher is capable of considerably more power. Here, I have it connected to a commercial switching power supply I bought from Amazon. It outputs about 280 volts DC, as well as the filament 6.3 volt. To test the power out, I have it connected to my power meter, but since it outputs more power than the meter can measure, I have it connected to the meter through an attenuator set to 10 dB. Therefore, full scale on the 1 watt range is actually 10 watts. So it's outputting about 4 watts. This is verified on the scope, just about 40 volts peak to peak into 50 ohms. I'll let you do the math. The end, folks. I hope you found this video very helpful. If you have any questions or comments, email me. Glad to help. 73 from KJ7 Uncle Mike.